Okay, so the function which we are going to deal today is tan square x. So first of all, let's make this equal to y. Y is equal to tan square x. And if you haven't watched my previous videos, the previous 3 to 4 videos, you are going to lack on some concept because these videos were actually very basic and we had discussed the very basics of the derivatives of trigonometric formulas. So if you have not watched these videos, I hardly recommend you to watch those videos so that you are not confused on anything going on this. Now let's make the increment in the variables. So y plus delta y would actually be equal to tan square x plus delta x. Okay, I'm going to move this y towards the opposite side of the equation. So delta y would be equal to tan minus y, and this y is actually equal to tan square x, so I can put the value of y as tan square x. Now you can see that this is the tan square x plus delta x, and this is tan square x separated by negative sign. This form can also be written as tan x plus delta x whole square minus tan x whole square. Now why did I do that? Because this is actually equal to a square minus b square is actually equal to a minus b, a plus b. You see, this is the same form right over here, separated by a negative sign. A square is 10. This would be my a. Okay, this would be my b. So we can write this as a minus b. What is a? Tan x plus delta x plus tan x, okay, multiplied by a minus b. Now what is a minus b? Tan x plus delta x minus tan x. Okay, now a trigger warning over here. You have to keep the term with the positive separation on the first and the term with the negative separation on the last. Why? I will explain this to you in the upcoming steps, but for now you just keep this in mind that we are specifically in this question keeping the positive term at first. Okay, so, and one more thing, we are not going to change this term anymore now. This term is going to move as it is. Okay, so every single step which is going to happen next is going to happen on this term right over here. Okay, so let's begin. Let's just rewrite this term multiplied by, now tangent is actually equal to sine over cosine. Okay, tangent alpha is actually equal to sine alpha cos alpha. So the alpha over here is x plus delta x, so I will write sine x plus delta x divided by cos x plus delta x minus sine x divided by cos x. Okay, the next thing which I can do is taking the LCM, cos x and cos x plus delta x. The cos x is actually not present over here, so it would be multiplied by the numerator, sine x plus delta x multiplied by cos x minus sine x, and we can see that cos x is present over there, so it would be cancelled. Cos x plus delta x is not present in the denominator, so it would be multiplied by the numerator, cos x plus delta x. Okay, and there's a bracket over here, x plus delta x multiplied by cos x, right? And then again sine x multiplied by cos x plus delta x. So there is a very specific sequence over here. This can be my alpha and this can be my beta. Now if you see, sine alpha multiplied by cos beta minus sine beta multiplied by cos alpha. This is the same sequence which we are using in the formula sine alpha minus beta, which is actually equal to sine alpha dot cos beta minus cos alpha dot sine beta. So we can actually write it as sine alpha minus beta. Okay, so sine, what is alpha? X plus delta x minus beta. What is beta? X. Now this is cancelled. And you see, this is the reason why I was keeping the negative term on the last. You see, if there wouldn't be a negative sign over here, there would be a positive sign over here, right? And if there would be a positive sign over here, we won't be left with sine delta x. Now, what's the purpose of having sine delta x? You will see. Now we can finally move towards the fourth step of differential using the first principle, and that is dividing delta x on both sides. So delta x divided by delta x. Okay, and this term can be rewritten as 1 divided by delta x multiplied by Now we can finally move towards the fifth step, and that is applying the limit. But before applying the limit, we know from the previous videos that before applying the limit in any trigonometric question, we want this sequence: limit of delta x approaches to 0 and sine or any other trigonometric function divided by delta x should actually be equal to 1. Now how can we do the same process over here? We can see that there is a delta x in the denominator over here, and there's a sine delta x over here. So if I just move this delta x from here to here, we can see that sine delta x is being divided by delta x, right? And if this is the case, we can apply the limit and this would be equal to 1. Okay? So this is how you do it. And now I can be pretty sure that you know that why we use the negative term instead of the positive term in the second place. Because if we were not using the second term, negative term in the second place, we won't have the delta x remaining at this step. Okay, so I hope that makes sense. Now let's just apply the limit. Limit of delta x approaches to 0, delta y by delta x. This is actually equal to delta y divided by delta x. Okay, so the limit of delta x approaches to 0, tangent. So I'm going to write this in this form: sine delta x divided by delta x multiplied by. Now wherever we are having a delta x over here, we can apply the limit. Okay, and these term, this term, and this term are being multiplied, so we can apply the limits separately on this equation. Okay, remember, we cannot apply the limits separately on this thing because it is being added. So remember, wherever the terms are being multiplied, we can apply the limits separately on those terms, but we cannot apply the limits separately on the terms which are being added. Okay, so this tan x plus delta x plus tan x will be having only one limit. Okay, what I mean to say is limit of delta x approaches to 0, tangent x plus delta x be added by tan x. This would be having one limit. Now this term is being multiplied, so I can write it as limit of delta x approaches to 0, sine delta x divided by delta x, and again these terms are again being multiplied, so I can also write limit of delta x approaches to 0, 1 divided by cos x multiplied by cos x plus delta x. Okay, this would be 0, and this would be 1, and this would be 0. So we have tangent 1 divided by cos x dot cos x. This would be tan plus tan is 2 tan, 2 tan x multiplied by 1 divided by cos squared x, and this would be 2 tan x. 1 divided by cos is actually equal to secant. So we have secant squared x. Okay, so this is the final derivative of tan square x.